Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 10.4, Problem 5. This is Section 10.4, Problem number 5. It says, Sally read on Facebook that 25% of adult Americans have at least one tattoo. As a project for one of her classes, she decides to use a hypothesis test to see if the claim is true for people in southeastern Massachusetts. In a sample of 1,200 local residents, she observes 345 with a tattoo. If Sally tests the claim at a 1% level of significance that the percentage of people in southeastern Mass that have a tattoo is different than 25%, what will the conclusion be? So this is a hypothesis test. We have 6 steps to do. The first step is to state the null hypothesis. So the symbol is a capital H with a subscript 0. We put a colon. And for most hypothesis tests, the next symbol is mu, which is the symbol for the mean of a population. But this one, since we're testing a percentage or a proportion, we use a p. And then the null hypothesis will always have the condition of equality. It will either be equal to, less than or equal to, or greater than or equal to. In this case, we're going to use equal to 25%, but we have to write it as a decimal. So as a decimal, 25% is 0.25. So now we do the alternate hypothesis. That's the next step. So it's a capital H with a subscript of 1. We put the colon. We'll have the same p. We'll have the same number, 0.25, but a different symbol. So for the alternate hypothesis, the symbol is always going to be either not equal to, less than, or greater than. So which one is it for this question? It's going to be not equal to, because we're just testing to see if it's different. So it could be a little less or a little bit more. So it's different, not equal to. So the third step is determine what type of test we have. Is it a left tail test, a right tail test, or a two-tail test? Well, whenever it's not equal to, it's a two-tail test, which means there's a critical region in each end or each tail of our graph. Now, how big is each critical region? The question says to test at a 1% level of significance. There it is, 1%. So you have 0.5% on each side. So that's not 0.05 for 0.5%, it's 0.005. 0.05 is 5%. We want 0.5%. So there's 0.005 on the left, 0.005 on the right. And if you go into either critical region, you will reject the null. But if you're not quite out into the critical regions, you're closer to the middle, you will fail to reject the null. So let's see where we wind up. So we go on to step 3, which is calculate the value for z. The formula for z is z equals x, the number of observed successes, minus n, the size of the sample, times p, the percent or proportion that you're testing, over the square root of n times p times 1 minus p. So fill it in. Z equals x. The number of observed successes in this case is 345. That's how many people Sally was able to find with at least one tattoo. Minus n, the size of your sample. So for this question, the size of the sample is 1,200. She examined 1,200 residents of southeastern Mass. So that's n times p, what we're testing, is 0.25 for 25%. And in the denominator, the square root of n times p times 1 minus p. So n, again, is 1,200 times p is 0.25 times 1 minus p. 1 minus 0.25, I'll just do the math right now. It's 0.75, right? 1 minus 0.25 is 0.75. So that's how it would fill in. And now what we'll do is we'll start doing some of the computation. So we will have z equals 345 minus 1,200 times 0.25 is 300. And then in the denominator, we'll have the square root of 1,200 times 0.25 times 0.75 is 225. Don't forget that's under a square root. So now we can do a little bit more work. In the numerator, 345 minus 300 is positive 45. Again, you want to pay attention to the sign. This is positive 45. In the denominator, the square root of 225 surprisingly comes out to a whole number. It's 15. And now if you divide 45 divided by 15, it comes out to a nice whole number of 3. So step 4, which is compute the value for z, we get z equals 3. So the next step, what we want to do is look up your value for z in the standard normal chart, which is at the end of the homework. So in order to look up some value in the chart, you have to write it so that it has 2 places after the decimal. 3 just by itself doesn't have any places after the decimal. So that 3, we want to start by writing it as a 3.00 if we want to look it up in that chart. So after you have 2 places after the decimal, you now split that number into 2 parts by pulling off the rightmost digit. So that last 0 comes off. You have 3.0 and then 0. And then the next step is to put a 0.0 in front of the rightmost digit that you pulled off. So it becomes 0.00. And now you go to the chart, the positive page of that standard normal chart, because there is a positive and a negative. And you're going to see where the row for 3 intersects with the column for 0, 0. And you'll see that it intersects at 0.9987. That's our value for z. So step 5, look up the value for z. We got it, z was 0.9987 when we look it up in the chart. So step 6, state your conclusion. So we're either going to reject the null hypothesis or fail to reject the null hypothesis. So the question is, did we go out into either critical region on our graph? Well, we are out into the right end, the right critical region. So what's the magic number to get past if the critical region is 0.005? It would be 0.9950 or just 995. Well, 9987 is bigger than 9950. So we are into the critical region on the right-hand side, which means our conclusion will be to reject the null hypothesis. We're rejecting the null, which means we feel it's more likely that the alternate hypothesis is the true statement, that the percentage of people in southeastern Mass that have a tattoo is different than 25%. In our study, it was more than 25%. So for the final step, step 6, state your conclusion. The result for that would be reject null hypothesis.